Okay, so for log function manipulation, there are three main properties of logs that we have to know, and we can use those to like combine logs or break logs back apart. So this is a skill that you just kind of need to know for being able to solve equations for this. So this section will definitely be a very like algebraic sort of section where we're just using this to manipulate these here. I can't remember. I don't think it actually gets into solving equations yet. That will come later in a later section. But we are going to learn these properties, which will later help us be able to solve some equations that we otherwise could not solve. So, for this, our product property tells us if we have log with a base of whatever, b in this case, of x times y, we can break that into log base b of x plus log base b of y. Okay, so this is just a property that is always true of logs. Honestly, I don't really know the proof of that. I could probably find it if you want, but I would say probably just take my word. This always works. So if I have something like the log base 2 of 5x, I could rewrite this as log base 2 of 5 plus log base 2 of x. They have to be the same base, yes. For the quotient property, if you have two things inside of your parentheses that are divided, then you can break it up using a subtraction sign. So something like log base 3 of y over 4 would equal log base 3 of y minus log base 3 of 4. Okay, and then the last property is your power property. And this tells us if you were doing the log of something raised to a power, then this power right here, that n, can be pulled out front as a coefficient. So it would equal n log base b of x. So for example, if I had log base 7 of 3 to the x power, this exponent can be pulled out front as a coefficient, and I would have x times log base 7 of 3. So there's basically two things we're going to learn how to do today. We are going to learn how to combine these to make one log, or we're going to learn how to take multiple logs, or combine them to make one log, or take one log and break it back apart into several logs for this. So for the first one, we are practicing condensing these down into a single logarithm. So like if I have I've got log base 4 of x plus log base 4 of y. Your bases have to be the same. If they are not the same, you cannot combine them there, but they are the same here. So I've got log base 4 of x times y. So when you're condensing, addition becomes multiplication for that. For b, when we condense that, I've got subtraction. So subtraction is my quotient property. I'm going to be dividing here. So I'll get log base 3 of 5 over z. Okay. Now C is going to be a little bit trickier because it's division, but I got three things going on, right? So you can kind of think, sometimes it's helpful to think about doing like order of operations. If I am subtracting, I just go left to right, right? These are all subtracted. So I could write this as log base 10. This is what I'm talking about. AP always puts the base 10. If you just wrote log, that would be fine because it's the common log. But AP pretty much always puts that there. So I got x divided by 5, and I could leave this off. And then I would have log base 10 of x over 5 divided by z. Now, chances are they are not going to leave that complex fraction. They don't like to leave a fraction inside of a fraction there. So what you're going to do for that is, let's make z a fraction by putting it over 1. And dividing fractions is easy as pie. We're going to flip the second and multiply. So whenever I do that, I'm going to have x over 5 times 1 over z. And then to multiply fractions, you just multiply straight across. So you'll get x divided by 5z. So this would equal log base 10 of x divided by 5z. And that is probably what you would see as the answer choice there. Okay. D is going to be a little bit different. It's division again, but I have got this 3 out front. You cannot combine a 3 times a log base 2 and a log base 2 together if they have different variables inside of them. So what you've got to do right here is you got to pull that 3 back in as an exponent, right? Because that coefficient is your exponent. So that's your power property. So we'll have log base 2 of x cubed minus log base 2 of y. And now I can combine those with division. So I'll have log base 2 of x to the third over y. So in general, you always want to pull any coefficients in as exponents first. So like when I look at E2, needs to go back inside as an exponent. You got some options right here. You can take 5 or you can take negative 5. I think it's easier just to take the 5 and leave the minus between those. If you take a negative 5, you're going to have like negative exponents to deal with, which will still get you the right answer, but it's a little more cumbersome to deal with. So we've got log base 7 of a squared minus log base 7 of b to the 5th plus log base 7 of 4. And then order of operations, when you're doing, please excuse my dear Aunt Sally, you're doing parentheses, exponents, multiplication, division, addition, subtraction. Addition really does not come before subtraction, right? Those two are equal. So you're just going left to right here. So you're going to do these first two. You'll do log base 7 of a squared over b to the 5th plus log base 7 of 4. And then with that addition, that becomes multiplication. So it will be log base 7 of a squared over b to the 5th times 4. Again, they're probably not going to leave it this way because they're probably going to want to combine that. So that 4 is not currently a fraction, but you can make it a fraction by putting it over 1. And to multiply fractions, you just multiply straight across. So you will get log base 7 of 4a squared over b to the 5th. Okay, questions so far? All right, what about F? Can I put anything together there? I cannot, because can I pull this in as an exponent? No, because that only works if I am multiplying out front by a number, right? If I'm multiplying. This is not multiplied, so there's no number to be pulled in right there. That won't work. Could I put them together and say, log base 6 of 2x? I cannot, because this first one did not have a log. So he's putting this one here to remind us that you can't always simplify things, right? So you would just have 2 plus log base 6 of x. Like, you can't do anything to it. Okay, questions? All right, example 2 is asking you to go backwards. It's asking you to break it back apart. So I have that square right there on the top. Does it go with the whole thing or just with the x? It's just with the x. So can I pull it out as an exponent right now? I cannot. I've got to break up that division first. So that would be log base 3 of x squared minus log base 3 of y, which is like correct, but is it an answer choice for us? It is not. So there's one more thing I could do to this. What else could I do? What do you think, Connor? That 2 could be pulled out as the coefficient. So I got 2 log base 3 of x minus log base 3 of y, and that one is right here. That'll be answer choice C. Okay, questions? Did you guys do this some in Math 3? Does it like seem familiar? Maybe. I mean, maybe not remember it entirely. I don't think you have to do it in 3, but I think it's one of those things Ms. Martin usually throws in. He might not have.
I think we definitely did the math too, because I literally got like a memory on my phone on Snapchat from 2 years ago today, like yesterday, and it was a vlog.
Yeah. Yeah. So, I think this is one of those things, like, if your teacher did not teach it to you, they weren't necessarily wrong. But sometimes we do. Go ahead and do it. So, the function f of x equals log of 6x is a horizontal dilation of the function g of x equals log x. By what factor? It didn't say by what factor, but by a factor of 1/6. We'll throw that in there just to remind ourselves what happens, right? So if you multiply by 6 on the inside, it's going to be a dilation by a factor of 1/6. Show that f can also be written as a vertical translation of g. Okay, so a vertical translation g, or we've got g of x plus k. Here, remember, g is just like log x, right? So what we're going to do here is we're going to use properties of logs to break this back apart. So if these two things are multiplied, I could write f of x as log 6 plus log x. They don't have a base written on here, so it's understood that it's a 10. If you want to put the 10 there, you can, but you don't have to. For this, notice that g of x is log x, right? That is that part right there. So what we've got here is f of x equals that log x is g of x plus log 6. What you must remember is that log 6 is a number. Our k is log 6. If you take your calculator, let me put mine up here. What's that one? If you take your calculator and type in log 6, it will give you a number. It's 0.778151, right? So it is this would be a vertical translation up log 6 or 0.77 whatever there. If it does, it'll be calculator active. So if it does, it'll be calculator active. You could see this on either one, really. There, I lean towards thinking it's going to be on calculator inactive, because if it is calculator active, you could just graph f of x and then graph your answer choices, and you would be able to tell which one matches without actually having to know how the properties work. So they just gave us this equation right here. F of x equals g of x plus k. So that k right there is that, they're telling you that's the vertical translation. So like log x is g of x. So this part of your function right here is the g of x part. So this other part is that k, it's the value that's being added. And since it's just numbers, like if you're doing log of just a number, there's no variable left, it is just a number. So, you know, you could type it into the calculator and get the actual number for it. Okay. Change of base property. We already looked at this a little bit for typing things into the calculator, particularly if you're using the handheld calculator. It's a lot easier because, like, if I want to do log base 2 of 7, like, let's just write this. If I want to do log base 2 of 7, right, I could type it into the calculator as log 7 divided by log 2. Now, because you guys get to use Desmos, and Desmos is much easier to type in logs, I don't know that you paid much attention when I was showing you that, because you could just do it the other way. But some of these questions are not going to ask us to find a value. They're going to ask us to rewrite a function. So the thing about this is, in your change of base formula, it does not matter what the base of your log is. If we are just typing it into the calculator, we are probably going to use log because it's an easy button to hit. But I could also do natural log of 7 divided by natural log of 2, and I would get the same number, right? No, I didn't get the same number. Why not? Oh, because I have 2 parentheses right there. Hold on. Should get the same number. All right, let me go back up. Oh, I'm just going to type it in again. Natural log of 7 divided by natural log of 2 at 2.807. We're getting that same number. And I'm going to flip over to Desmos to show you this. Like, there's no real reason why you would ever want to do this for just figuring this out. But if I do like log base 3 of 7 divided by log base 3 of 2, same number that I get right there, that 2.807. So, you know, if you were trying to type it in the calculator, there's no reason you would ever do a log base 3 for that. You would do one of them that's easier to type in. But when it comes to transforming functions to a different base, you might. So let's look at
the other way you would do that would just be put in log base.
Like log base 2 of 7, yeah. And so since you guys can use Desmos, if you're just having to evaluate that, that's probably the way that you would do it, because it's pretty easy to type into Desmos for that. Oops, that's the wrong thing. Where's my, there we go. Okay, so it says let f of x equal log base 4 of x and g of x equal log base 9 of x. Show that f is a vertical dilation of g by finding the value of k such that f of x equals k times g of x. So if we look at what's supposed to happen here, I am starting off with f, which is a log base 4. And I'm supposed to get some number times g, which is a log base 9, right? So I'm needing to change a log base 4 to a log base 9. So if I use the change of base formula, I'm starting with log base 4 of x. And the rule here tells me that I can do, like if I want to type this into the calculator, I could do log x over log 4. But that does not change this to a log base 9, right? That would be a log base 10. But those a's right there, it doesn't matter what number that is as long as they match. So instead of doing log x over log 9, I could do log base 9 of x over log base 9 of 4. And so here we should be seeing like g is log base 9 of x. There, that right there is the g, right? So this would be like g of x over log base 9 of 4. That still doesn't like look like a number times log base 9 of 4, right? But I could write it this way. I could do 1 over log base 9 of 4 times g of x. Because if I were to multiply that back together, g of x is not a fraction. I'd put it over 1. I'd multiply those across. I'd still get that same thing. So this part right here, of course, is my g of x. This part right here doesn't look like it, but it is a number. That is your k, right? So depending on whether this is calculator active or inactive, I could say k is 1 over log base 9 of 4 if it's calculator inactive. If it is calculator active, then I could do 1 divided by log base there. Log base 9 of 4. And I get 1.585. So depending on whether it's calculator active or not, you could give either one of those as your answer. So sometimes this may be used not to type stuff into the calculator, but to rewrite it with a different base. Okay, questions there? All right. I have already shown you the natural log function. I think he's introducing it for the first time in the notes here. Log with a base of e is a natural log. And so all the same rules apply to natural logs as they do to any other type of log. It's just a different base. So if I have something like this, 3 natural log of x minus 4 natural log of y, then I would be combining these just like I've done the others. First thing that has to happen, exponents have to be brought in, or coefficients have to be brought in as exponents. So that would give me natural log of x cubed minus natural log of y to the 4th. And then that's going to be division whenever I have subtraction. So that's going to be natural log of x cubed over y to the 4th. There. And so A would be my answer for that. Okay. Questions?